Okay, welcome back to C++. This week we are working within Chapter 6, a chapter all about functions. Let's take a look at the list of topics for this chapter. We're going to take a look at what is meant by modular programming. Functions help us out greatly when it comes to doing modular programming. So far we're just doing sort of what I would call sequential programming, where basically the code executes from top to bottom without deviating too much. We have talked about if statements, loops, things like this that can sort of branch off the code in different directions, but when we get into functions, we really talk about moving into different areas of the code when needed to execute various pieces of functionality. So we're going to look at what it means to define and call a function. So this is very much a two-part exercise. We have to define what the function is and what it is supposed to do, and then we have to use the function. Now, so far, even yet this semester, we have done this part. We have called functions. Now, they aren't functions that we created necessarily, but we have called them. We've called other functions that are, I guess, built into the C++ programming language. We'll see what is meant by function prototyping. This is a point on functions that I guess I would say is unique to C++. You don't really see function prototypes in other programming languages, so I'll try to point that out when we get there. Sending data into a function, passing data by value. This is probably one of the more confusing parts of working with functions in C++, and really any programming language, I guess, is this idea of passing by value and by reference. We'll take a look at the return statement, which we have seen so far in our main function. We'll look at returning a value from a function, returning a Boolean value, using functions in a menu-driven programming, local and global variables. Bit of a shift in topics here, I guess, but when we talk about functions, this idea of scope becomes even more important now than it ever has been. We have talked about scope a little bit so far, but when we start branching off into different functions, then this idea of variables, when they come into and go out of scope, is really, really important. Then we'll take a look at static local variables. We'll look at how to define arguments to functions. And then before I said that passing parameters by value is one of the more confusing parts of functions in C++. Sort of the partner to that is passing parameters by reference. So there's this idea of passing by value and by reference. We'll look at what it means to overload functions. We'll take a look at the exit function, and then we'll see what it means to use stubs and drivers in our programs. Okay, so what is modular programming? Modular programming is breaking up a program into smaller, more manageable functions or modules. Those two terms are sort of interchangeable in computer programming. Supports the divide and conquer approach to solving a problem, so breaking a large program down into smaller sub-problems that are easier to solve. And then all of the sub-problems get solved and sort of work together to support the solving of the larger or original tasks that we're trying to complete. So what is a function? Defined, it's a collection of statements to perform a specific task. That's it. A group of, most of the time, like statements to perform a specific task. There are religious wars on like how long your functions should be. What should they do? Should they do one thing or should they do many things? We'll try to take a fairly practical approach here when it comes to defining our functions. Motivation for modular programming. So why do we do it? Generally speaking, it simplifies the process of writing programs and improves maintainability. So if we have a program, it's a large program, it's doing some, I don't know, financial calculations, and somewhere within the program we have a function that would calculate the average of three numbers. Typical traditional sort of computer programming function. If we suspect that there may be something wrong with the average function, we can locate the function and troubleshoot it once in one spot. It's not like we're having to recalculate the average all over our programs wherever we need to calculate the average. We define the function to calculate the average, and then we can use that function to do so whenever we need it. So two parts: function call, a statement that causes a function to execute, and a function definition, the statements that make up the function. So the definition basically tells it what it's going to do. The function call is when you actually execute the function, when you actually run the function. So a little bit on syntax here. So a function definition includes the name of the function. So sort of like naming our own variables, we have to name our functions. Function names follow the same rules as variable names, so that's nice. We don't have a new set of rules that apply to only function names. Then we see a parameter list. The variables that hold the values are passed to the function when it is called. This may be empty. Functions do not have to have parameter lists. The body of the function is kind of the meat, or the statements that perform the function's task. So in terms of the average three numbers function, that would be the actual math that calculates the average of the three numbers. The three numbers in that example would be the parameter list. So number 1, number 2, number 3 would be your three parameters. The body would be crunching the numbers, and then the return type would be the actual average that you're returning. The data type of the value the function returns to the part of the program that called it. Here's what it looks like using a familiar example. So in this, again, familiar example, we have int main. So the int, that's a familiar keyword. That is the return type. So we're saying here that the function called main, a very special function in C++, is going to return an integer, which we've tried to be good about doing. We've always tried to return 0 in our main functions. So main, yes, is the name of the function. Then we have open, close parem, which will contain your parameter list. And this one happens to be empty, doesn't have to be. Then we have the open, closing curly, and inside of those we have the body of the function, or what the heck is it going to do? And then finally we have the return value that we've promised that we're going to return up here with our return type. So the function header, and yeah, we'll get to a hands-on here soon. The function header consists of the function's return type, the name, and the parameter list. And again, if we look back at our example here, we have those three things here. We have the return type, we have the name of the function, and we have the, in this case, empty parameter list. Those three things are called the function header. An example is int main. There's no semicolon at the end of the header. Of course, we never put a semicolon after the closing paren here. The return type. If a function does return a value, notice if a function returns a value, does not have to, the type of the value must be indicated. So with main, we've promised that we're going to return an integer. If a function does not return a value, its return type is void. So it's perfectly acceptable for a function to not return any values. In this case, this function has no inputs. And I should mention back here, what goes in the parens, those are sometimes, you could think of that as being your inputs to the function. And the return type is sort of like your output. So in this case, what I always say is we have no inputs, we have no outputs. This function is simply doing something. In this case, it's just printing some text to the screen using cout. So that was defining the function. This is a very, very simple function called print heading that just prints something to the screen. Calling the function is simply writing the name of the function followed by open, closing paren, semicolon. When you call the function, you do have to use the semicolon at the end. And depending on if the function has any parameters, you may have additional things inside of the opening and closing paren. Because this function definition had nothing in there, when we call it, we don't supply anything. When the function is called, the program executes the body of it. And after the function terminates, execution resumes in the calling module at the point of the call. So all that's doing is saying, once print heading is called, goes and does its thing, it prints. Regular execution of the program is going to continue on the next line right after print heading. And of course, we'll see an example of that coming up soon. So of course, main is the function that's automatically called when the program starts. Main can call any number of functions inside of it, and functions can call other functions. So you can have functions and functions and functions, as many levels deep as you want or need. Let's finally do a hands-on on page 330. And yes, this is chapter 6. Let's create a new project. Project name, EX6-1. Solution name, chapter 6. Let us clean this up. And let me get my screen organized. Like so. Page 330. Okay. Simple function here. Okay, here's something that we didn't necessarily get into in the slide, but I'll just show it to you here. What we have here is something called the function prototype. This is all it is. Notice when we sort of declare or prototype the function, this is done outside of main. And what this does is it sort of gives main a preview of what the display message function is going to look like. The main purpose of it is to give it a name, specify its return type, and also specify what the input parameters are. In this case, again, we have no return type, no inputs. So when it comes to these functions, we're going to take the approach where we're going to prototype it up above first. And then down below, we say it again, void display message, open close paren, open close curly. And this contains our function definition. Cout hello from display message. Okay. Now, just to make it kind of obvious how the general flow and execution goes here, we'll cout hello from main. Then we'll call display message. You'll notice the autocomplete there helping me out. Cout now we are back in main. Cool. Now let's see how this function kind of moves, how the program moves and flows from start to finish. So we have hello from main, that's to be expected, then display message. So when we reach that, then we're going to jump down here, print out this message, and then go back to where the function was called and say, now we're back in main. Okay, so notice, again, really three different things here. We have the function prototype, which goes up at the top outside of main, which gives main a preview of what this function is going to be as far as inputs and outputs. The actual definition of it is outside of main, below main. Then inside of main, we can call that function over and over again if we wanted to, if it actually was doing something useful. Whoops. There we go. So now we call that function twice, so we see that message displayed 2 times. Hopefully that was somewhat straightforward. All right, let's jump to the next one on the next page. Let's keep it within the same program. We can also call that function from within a loop, which is what this program is supposed to illustrate for us. So a little review from last chapter, I think. We'll enter into a for loop. For int count equals 0. Count is less than, say, 3. Count plus plus. And then we can call display message. Output is what we would expect. So prints it 3 times here. Again, just illustrating that you can indeed call a function inside of a for loop. Let's see if 6.3 is anything more interesting. Well, yeah. Let's keep it again within the same program. void display message. We'll say void display message 2, just so you can see. We can use numbers in function names, so I prototype it up here. I'm going to define it down here, but check this out. Visual Studio is trying to be helpful to us and say, function definition for display message 2 not found. I prototyped it up here, but I never defined it down below. So if you want to, you can have Visual Studio create the definition of display message in here, and it'll just pop it up right down here. Now, it's not terribly useful for us here, but in the GameDev2 class, where we create functions that have like bizarre and, to be honest, somewhat scary function signatures, they have a lot of inputs and very complex outputs. That feature in Visual Studio is kind of nice to not have to retype this a second time for very, very complex function signatures. Okay, so with this, we'll just say hello. Hello from display message 2. Oh, maybe we'll call it here. Okay. Display message, and then message 2. So again, just so you can see the general flow of execution within a function, within a program that has various functions being called and control flow being passed around. Cool. Got that guy. One more here. I think we'll skip over this one. This one's just showing us, hey, we have 3 functions now instead of 2. All right, back to the PowerPoint. Function prototypes. So yes, this is what I mentioned in our examples. So you already have a preview of what this is. So the compiler must know the following about a function before it is called. So it needs to know its name, the return type, number of parameters, and data type of each parameter, which is again what you see in the prototype. Many ways to notify the compiler about a function before making the call. So we could put the function definition before calling the function, or we could use a prototype. So what that means is that if we wanted to, we could put these functions up here. We could put their definitions up here in place of the prototypes, and then main would know about them just fine and everything would be good. General practice, though, is to use your function prototypes here. We get into object-oriented programming when we get into something called class files and header files. The header file is kind of where you see the prototype for the different functions or methods, is what they're called in object-oriented programming. You see those prototypes show up in those header files. So to sort of give us a preview of where we're headed with more complicated programs, we'll take the approach of using the function prototypes. And again, notice that the header of the function is the exact same as the function prototype. Only the prototype does use a semicolon. The function signature down here in the implementation does not. Some notes. Place prototypes near the top of the program. A program must include either a prototype or a full function definition before it is called. Otherwise, the compiler will complain. When using prototypes, the function definition can be placed in any order in the source file. Traditionally, main is placed first. All that is doing, or all that is saying, is that, hey, main needs to be aware of these 2 functions before they're actually defined, before we actually implemented the functions. One other thing that's kind of nice about using prototypes is that we have kind of a little library of functions near the top of the program outside of main. That gives us some clues about how this program is generally structured and what kind of functions we're going to encounter in it. And if the programmers did their jobs, we should have meaningful names for the functions. We would see what their outputs are as well as what, if any, inputs there are. So it's a nice little kind of concise view, high-level view, of all the functions contained in this program. 6.5, 336. We'll just take a peek at it. This program has two functions, main and display message. There's no prototype for display message, so it must be placed before the main function in order to be called. So this is just illustrating what we were just talking about. There is no prototype here. The function signature appears here, and then its full implementation appears right after it. Then, if we flip to the next page, we can see that main appears and display message can be called just fine. So if we only had that implementation beneath main, outside of main, it would cause a compile error because main wouldn't know about the display message function. Let's take a minute and talk about sending data into a function. So in other words, passing data into, or like specifying what inputs the function is going to accept. You can pass values into a function at the time of a call. For example, we've seen the square root function accepts a parameter, or what number do you want to take the square root of? And here we're going to take the square root of a times a plus b times b. Values are passed as arguments. Now, I use these terms interchangeably. They aren't technically the same thing, but I don't think anybody's going to care too much if you don't get the usage exactly right. Technically, when you pass values into a function, they're called arguments, but the variables in the function that hold the values are called parameters. That's a little bit confusing, and again, I get the two kind of mixed up all the time. I'll show you exactly what that means when we get into a program, but if you interchange them, I wouldn't be too sad as long as you know how to use them properly. So alternative names for these, so again, you can call them arguments, actual parameters, formal argument, formal parameter. You know me, I'm not too formal when it comes to a lot of this stuff, so I'll take arguments, parameters, whatever. Inputs, outputs. If you want to be even more generic, they are inputs and outputs. Okay, for each function argument, the prototype must include the data type of each parameter in its parens. It may also include a parameter name. So this is kind of interesting. Again, I wasn't quite aware of this. I would consider this bad programming practice. If you have a function called even or odd, it's not going to return anything. It's going to return void, but it accepts an integer, basically the number that you want to check for even or odd. All you really have to do is specify the data type. I don't like this. I don't think this is detailed enough. Here is a similar example, and here they specified the data type and the name of the input that you're going to pass to this function. So the header must include a declaration with the variable type and name in its parens. So while the prototype doesn't need to have the name, the header of the function or the function signature does need to have it. So I say, why waste brain cells trying to remember that distinction? And I would say just always include the input data type and the name. And then the call to the function, you just specify the thing that you want to pass in. So even or odd, I want to check to see if val is an even or odd value, integer. So the value of the argument is copied into the parameter when the function is called. A function can have more than one, so it can have 0 or more. And there must be a data type listed in the prototype, parens, and an argument declaration in the function heading for each parameter. Arguments will be promoted or demoted as necessary to match parameters. Be careful. Yes, let's take a look at some examples of these. So page 338. Let's fire up a new example. So 6.6. All right, we've got our function prototype. So void means it's not returning anything. Function name, display value, passing in an int called num. We'll jump down to the definition, void, display value. Input is int called num. All we're going to do is cout. The value is num endl. Let's activate it. Whoops, we didn't call it, did we? Not an uncommon mistake. So what are they doing? So cout, I'm passing 5 to the function. Display value, passing in some number 5. Now I'm back in main. Cool. So the value is 5, now I'm back in main. So just to really drive this home, we can say display value 10. Value is 5, the value is 10, now I'm back in main. Okay, so the actual number 5 is passed into display value as an input, and it's substituted in for num. Num contains 5, and it's printed out with an end line. When this guy is called, 10 is being passed into an input for the display value function. The value is 10, substitution, end line. Okay, basic inputs. Oh, this is kind of what we just talked about, so I won't waste time rewriting this. So again, they're just calling the same function with different inputs. Display value 5, 10, 2, 16. Now I'm back in main. Sample run of the program is exactly what you would expect. Notice that we're using an integer parameter, not a string or a char or some other object, strictly an integer. Functions with multiple arguments. So when calling a function with multiple args, abbreviated args sometimes, the number of arguments in the call must match the function prototype and definition. The value of the first argument will be copied into the first parameter, value of the second into the second parameter, on down the list. Here's what that looks like. So if the function implementation looks like this, void display data is going to accept 2 parameters. It's going to accept an integer called h, comma, and an integer called w. And all it's going to do is print out what they are. Height equals h, weight. I assumed width. Weight equals, and then whatever is in w. When you call the function, you pass in whatever you want for height, whatever you want for weight, and those two are substituted down here for h and w, and are simply displayed in the standard output. All right, let's get some practice with this. 6.8. Standard namespace. Okay, void show sum. It's going to accept 3 inputs, an integer called num1, comma, an int called num2, comma, int num3, semicolon. Let's right away jump down here, void. Now I want to show you. So now we have a little bit more syntax here. And in order to make sure I get that right and to save my precious fingers from having to type too much, I can click on show sum, create definition of show sum, and boom, it shows up. Thank you, Visual Studio. So we're going to cout the sum, the sum is num1 plus num2 plus num3. End line. Cool. So inside of main, we have 3 variables, int value 1, value 2, value 3. Now we're going to prompt the user, cout, enter 3 ints. cin value 1, value 2, value 3. And now we will call show sum with those 3. Whatever is in value 1, comma, whatever is in value 2, comma, whatever is in value 3. Simple substitution. Whatever the user enters for value 1 is placed in value 1, is sent down to the show sum function, substitute in for num1. What I wanted to show you with this is notice how they're different names. So we didn't have to pass in a variable called num1, num2, num3. That's what they're defined as in the function implementation and prototype. But we can pass in whatever we want. In this case, we're grabbing it from the user to display, but we could have hard-coded those in as well. Let's see what the book wants to run. 487. Sum is 19, which sounds good to me. Okay, passing data by value. So pass by value. When an argument is passed to a function, a copy of its value is placed in the parameter. The function cannot access the original argument. Changes made to the parameter in the function do not affect the value of the argument calling the function. If there's one thing that trips up new people, it is this idea. So try to pay attention and follow these next few examples. This next slide and example. Make sure it makes sense. It is very, very important, especially when we get into object-oriented programming, and those of you taking Game Dev 2 will need to know this pretty well, pretty solid grasp of this. Okay, passing data to parameters by value. So if we have an integer called val equal to 5, and we pass that variable into an even or odd function, if even or odd changes the variable of num, it will have no effect on the variable val. So val is 5, argument in the calling function, passing it to the even or odd function. If even or odd messes with that value, the original val is left unchanged. Let's see what the hands-on looks like for this. I may add my own spin to it. Page 343. Sometimes it's easier to just do the thing rather than talk about the thing. 6.9. All right, void change me accepts an int called a value, some value. Down here, a void function called change me accepts an int called my value. Here, notice the parameter names do not need to be the same. They must match data type, but they don't have to have the same name. So a value up here, my value down here, doesn't matter so long as they're both integers. Okay, so when this function accepts an input called my value, take it and say my value equals 0. Then display it. So in the function, the value has changed to my value. Fine. Nothing too surprising here. So we know when this guy runs, we're going to see 0. My value is changed to 0. However, up inside of main, let's declare an integer called number, assign it 12, display it. In main, number is number. Now we're going to call change me, pass in number. That's fine. Now we'll say cout after change me. Number again. Okay, so try to follow this. I'll explain it, then we'll see what it does. So we have this integer called number, which we're going to display first. So number is going to say 12 here. Then we're going to pass number into change me. When we get down into change me, this is going to be 12. We're going to reassign that 12 to a 0. So down here, we're going to see in the function, the value has changed to 0. The interesting thing about this is when we get back out of the function, come back up here to this cout statement, what do you think number is going to be? Well, you wouldn't know if you didn't just see probably that last slide. Number is going to be its original value of 12 because we passed in a copy of this variable to the function. We passed it in by value. That's what that means. We're not actually modifying this variable when we pass it into the change me function. We're passing in a copy of it. And we're modifying the copy down in the function implementation, not the original value. Let's just prove that. Oop, forgot to activate. Cool. All right, so in main, the number is 12. In the function, we changed it to 0, but when we get back to main, it's still 12. Again, that is passing parameters by value. Okay, so we've talked about inputs. Let's talk about outputs. So outputs from a function are used with the return statement, so can be used to end execution of the function. That's also a good point. So the return statement means basically the function is done. It can be placed anywhere in the function. Statements that follow the return statement will not be executed. So once you see a return, that keyword return in the function is done. It can be used to prevent abnormal termination. Without a return, the function ends at its last closing curly. So you've noticed, hopefully, in our functions so far, they've all been void, so we haven't even used the return keyword. If your function is void, it does not need a return keyword, and execution ends after the closing curly brace. Okay, on the other side of the return statement can be used to return a value from the function to the module that made the call. So we can return a value from the function to the thing that called it. In our case, that's been main, int main. So the prototype and function header must indicate the data type of the return value, not void. The calling function should use the return value like assign it to a variable, send it to cout, use it in some kind of math, or use it in an expression. That's the point of the return value. If you don't need to use the thing that the function is basically doing, you don't need to return it. Like we've just been printing out values, so our functions have been void. Okay, so the format or the syntax to this is return, keyword return, followed by the thing that you want to return. And the thing that you want to return usually is a variable. So I like to keep my return statements small. I don't like to do a lot of stuff in the expression here. I like to just say return this variable, return this value. Could be a variable, could be a literal value, or some other more complex expression. And that expression should be of the same data type as the declared return type of the function, and it will be converted if not, willingly or unwillingly. Okay, we'll see some examples of returning values in some examples here moving forward. So you can return a Boolean from a function. That Boolean or that function can return true or false. You can declare the return type in the prototype and the header as bool. So we've seen like int return type, we've seen void. You can say bool as your return type. So the function body must contain return, and it must return a true or false, or bool variables or expressions. The calling function can use the return value in a relational expression too. Here's an example. Here we have a function. This happens to be the prototype called isValid. It returns bool, not void. We've only seen really void or int here, but now we see bool, isValid, pass in one parameter called int. But again, I would like to see that. And semicolon. Okay, here's the, where'd it go? Hello. Yes. Here's the implementation. So is valid. So we're going to declare two local variables inside of this function, an int called min and max. Min is 0, max is 100. If the value passed in is greater than or equal to min and less than or equal to max, return true, otherwise return false. And the call to that could look like this. So here's a new little piece of syntax. In this case, they're calling the isValid function from within an if statement. There's nothing wrong with that because if you remember from that chapter, an if statement's condition must be something that is true or false. And in this case, we have a function that will return something that is true or false. So we can pass in the function followed by our score parameter, whatever that is, defined somewhere else in the program. And ultimately, we're going to get a true value or a false. And that's what our if statement wants and needs. All right, hands-on 346. Yes, this will be good. What number is 610? Function prototype void divide double arg1 double arg2. Void divide double arg1 double arg2 parens if arg2 is equal to 0.0 cout sorry can't divide by 0. A very important thing to check for in your code. And then return. Since this is void, we don't actually need to return a value here. Oh, this should have gone with the previous slide. Sorry about that. Slides are a little bit mixed up. This is just demonstrating a return value. Cout the quotient is arg1 over arg2, end line. Don't need to return here. This is kind of a subtle point, and I want you to try to get this. Yes, the return type is void. So we say return here, but we're not actually returning anything. We're just saying get out of the function, end it. If arg2 is 0, that's a problem because we can't divide by 0. So what this is doing is saying if it is 0, print a message and then return or get out of the function and don't execute this. Remember when return is encountered, control is returned to basically the calling function, in this case main. So let's call it. We'll just prompt enter two nums cn num1 num2. Call divide num1 num2. What's wrong with the syntax? Oh, I need to declare double num1 num2. Okay, if arg2 is not 0, if it's something else, then this return statement is skipped. And then we actually do the division, and then the return statement is implied because there's a closing curly down here. Let's look at a sample run. Example 10. Oh, these things do not stay in order. Set a startup. Two numbers, 12 and 0. Sorry, I can't divide by 0. Returns, and the program ends. Okay, a note on programming style. So a function may calculate a return value and use a single return statement. Previous example could be written like this. So in this case, what they're doing is sort of they're using an intermediary variable, I would call it. So they're still passing in a val, and they're setting their basically lower and upper bounds and checking to see if val is within those bounds. If it is, assign the value true to result, otherwise assign the value false to result, and then return result. So over here we had two return statements, and we returned inside of the if and the else. Down here, we're just doing assignment inside of the if and the else, and then we're returning after the if else is done. I like this method better because there's only one return statement. We're using that intermediary variable, I think, to make execution a little bit clearer. Another hands-on, 349. Yes, let's do this. All right. Function prototype called sum, accepting two inputs, num1, num2, both integers, and returning an int. Let's see what it's going to do. Int sum, int num1, int num2. I'm going to show you a couple different ways you could write this. So in this case, we're just, and what I would call this is inlining the return. So you can return num1 plus num2. And here's what that would look like as far as calling it. So we could say int value 1 equals 20, value 2 equals 40, and then a total, which is an int that is not initialized to any value. So now we say total is equal to a call to sum value 1, comma, value 2. And then we can display it, cout sum, print out total, and then return. So try to follow that. This really does demonstrate a return value quite nicely. So we've got two values here that are initialized to some number. We're passing in those variables to the sum function. Sum is entered with substituting value 1 for num1, value 2 for num2, and we're returning num1 plus num2. That's basically this, but then we're taking what is returned by this function and assigning it to our total variable, and then printing it out. So this is really the use case, or why we would care about or want to use a return statement inside of a function. You want to take the thing that the function gives back to you and assign it to something else, presumably. Now, I told you I was going to show you another sort of alternative way of doing this. This is like the quickest, most inlined way. You could also do this. Int, I almost said var, I've been writing C# code too much. So int total equals num1 plus num2, and then we can return total. A little bit more wordy, a little bit more syntax, but you could do it this way. And I guess we should run it. So 11. Whoops. I hit a key. Sum is 60. Cool. 351. Let's do another. Okay, this is good. Let's just read this guy kind of from top to bottom after I take a drink of water. So actually two useful functions here. One function is prototyped as getRadius. It accepts no inputs and returns a double as output. Another function is called square that accepts a double called number and returns a double. And let's take a look at what those functions do. So getRadius declares a local variable called rad inside of it. enter the value of the radius of the circle, cn rad, and then return rad. So you can use cin statements inside of function definitions. I believe that's the first time we've seen that. That's totally fine to do. Okay, so all that's doing is prompting for a radius and returning it to the calling code. Skipping a page here to see what square does. So square accepts a number and returns a number times itself. And yes, it does return it. So flipping back up in main, we're declaring a const called pi with the value of pi, declaring two local variables called radius and area, setting some formatting here. Then we're going to get the radius. So cout a prompt basically, and then we're going to say radius equals get radius. So another example of assigning the returned value from a function to a variable in main. So get radius, if we jump down to it, remember returns a double. It returns whatever double was entered in by the user. And then radius stores that value. We're taking that stored value and saying area now equals the constant pi times whatever the square of that radius is. So again, radius is passed down into the radius function, that value. It is returned and substituted in this mathematical calculation. So pi times whatever is returned by square radius. Make sure that makes sense. It's all about substitution. And then it just displays it and the program terminates. Oh, here's our returning a bool example. We'll just talk through it. So int val, we're going to test that. We have a function prototype is even, accepting an int, returning true or false. And basically we're going to prompt the user to enter a number and the program will tell them if the number is odd or even. So the is, oops, let me back up one. Right, so that's the cn. Indicate whether it is even or odd. So we're going to test it. If is even, print out val is even. Else it must be odd, so print out that it's odd. So notice here that we've used a function call inside of an if statement's condition. That's totally valid. So is even comes down here, accepts an integer. If the number modulus 2 is 0, that means there's no remainder. So the number is even. Otherwise it's false. And the if statement can use that fact. It can use the fact that it is even returns a true or a false. Cool. Alrighty, shifting gears a little bit, using a function in a menu-driven program. So functions can be used to implement user choices from menus. So if a user enters menu option 2, just call whatever menu option 2 represents. Call that corresponding function. To implement general purpose tasks, higher level functions can call general purpose ones. Minimizes the total number of functions and speeds to program development time. At least that's the idea. Side note, screen management in a menu-driven program. This is some old school stuff here. You can clear the screen to remove prior output while a program is running. So in Windows, you could literally just type this into your C++ program, and that CLS there stands for clear screen. If you're coding on Linux or Mac, you could use this guy to do the same thing. So that will clear out any previous output and give you basically a blank slate or a fresh screen to display your output. To allow the user enough time to read the output before you clear it, you can do something like this. A little bit of a hack. So like this is that press any key to continue hack that I told you about several classes ago. So you could do a cn.get, and that would be like your any key press. Let's check out this hands-on 355. This would be a good one. Example 614. several includes. Include, my favorite IO manip. Include string. Use a standard namespace. Here we're going to encounter our prototypes. So this is, again, a nice little library of functions. So void display menu int get choice and void show fees. String. So this is our first example of seeing a string as a parameter to a function. String category double rate int months. So again, gives us a little preview or a little hint of what kinds of functionality we're going to see in this program. Let's jump down to the function implementations, and just to save some typing, I'm going to say Visual Studio, you go ahead and help me out here. Especially with the show fees function. There we go. Okay, when we want to display the main menu, we're going to call system CLS to clear the screen. So give the user a fresh view of the main menu, cout. I'm going to abbreviate this as I generally do. So one is going to say, actually CLS, we're printing a header here. Health Club. Sure. Cout. One is going to be standard. Two is going to be child. Three is senior. And then four is quit. Okay, simply a bunch of couts with a clear screen up top. Let's see what get choice is going to do. This is kind of cool. So we've got a local variable called choice, which is an int. We're going to cin choice. And then while, here's a good review of while loops. So while choice is less than 1 or choice is greater than 4, we're doing some bounds checking on our choices to make sure it's a valid menu choice. While that's happening, we're going to cout, or if I can type, valid choices are 1 to 4. Try again. Cin choice. And try it again and do that over and over again until they get a valid input. And we're not going to return 0, we're going to return choice. So Visual Studio added that return 0. That's one of the disadvantages of using like generated code, is sometimes you can take it for granted and not realize that you have to change it. So in that case, we had to change 0 to choice. And now we're going to implement the show fees function. All right, so we've got all of our inputs. We're going to cout endl and then cout. Yes, this is good. So membership type. Member, oops. So check this out. We've deviated slightly from the example. No big deal, just worth pointing out that since we use Visual Studio to generate this function implementation, it kept the parameter names the same. So category up there is category down here. In the book, they called it member type. So they changed that name. Again, no big deal. We just need to be consistent. So we'll use category. Bunch of spaces, cout, number of months, total charges, we need a $, close double quotes, here's some math, rate, times, months, endl. Comment, hold the screen until enter key is pressed. Press enter to return to menu. And let's do a new line here. cn.get clear buffer. Got to do this twice, and I need a semi. Clear the input buffer, and then do a cn.get to wait for enter. All right, so now we can go back a page and see how we're going to be calling these functions in main. Yes, so we got several constants here. So const double adult rate equals 120. Const double child rate equals 60. Const double senior rate equals 100. Int choice, int months. Do some formatting here. Cout fixed, cout show point. Set precision to 2 for currency. Here we're going to do a do while. Remember my rule for do whiles. So as soon as you enter into the do, as soon as you type do open close paren, immediately jump down to your while and say while choice is not equal to 4. As soon as it becomes equal to 4, and semicolon there. When it becomes equal to 4, that means we're exiting the main menu and we're going to return 0 out of main. Okay, so inside of the do, display menu, so show the user the menu. Choice equals get choice if choice not equal to 4. Cout for how many months? Cn months. We're going to switch. This is a good comprehensive program here. A lot of stuff we've learned already. So we've seen months, switch choice case 1. Here we're going to call the show fees function. Show fees for adult rate months. Semicolon. Let me try to format this for you. Speaking of formatting, Visual Studio doesn't like to indent the case. I'll do that manually. And then we will break. It's never done this quite right. Case 2, show fees. Pass in the string child rate months. Break. Case 3, show fees. Senior rate months. And we're good. And we got the while. Everything's cool. Let's see what the book uses for sample input. Let's make this our startup project. Run it. All right, so yeah, I guess it would have been nice to say, hey, push a button, 1 through 4. Oh well, let's try standard. For how many months? 3. Membership type, adult, number of months 3, total charges, 360. And now we can do it again. So notice that CLS, that clear screen. So all I see is the main menu. I don't see the previous inputs and outputs from the user. We hit a 4 and we quit. And that's nice. That's why functions are helpful, because we can reuse the same code and not have to write the same thing over and over again. All right, some notes on global and local variables. So local variables are defined within a function or a block and accessible only within that function or the block. Parameters are also local, as we saw. Inside of show fees, that's the only place I can use category, rate, and the months variables. Main does not know about them. Certainly getChoice does not know about them, and DisplayMenu doesn't know about them. Those are local variables to the showFees function. Other functions and blocks can define variables with the same name, so we can use same names. If I had inputs for getChoice, I could have inputs called category, rate, and months, because again, they're local to that function. When a function is called, local variables in the calling function are not accessible from within the called function. Lifetime. So a local variable only exists while it's defining function is executing. Created when the function defines them and destroyed when the function terminates automatically for us behind the scenes. Data is not retained in local variables between calls to the functions in which they are defined. Probably just take a peek at this one, page 359. Okay. Just showing us again the difference between local variables and, as we're going to encounter soon here, global variables. I think I see a typo. They got a stray curly brace there, closing curly brace. Anyway, so we've got a void function called another function, which if we jump down there, we've got an int num equals 20, and we're just printing out the number 20. Then back inside of main, we've got an int num equals 1. Because of variable scope, and the fact that num is local to main up here and num is local to another function down here, we can definitely use them like this without any compile errors or warnings. If this seems confusing at first, it did to me too. Don't worry, as you program more and more, it becomes second nature. You don't even really have to think about it anymore. It's just obvious that, yeah, I have num down here, which is 20. It's totally fine if I have num up here, which is 1, and use it as though it was 1. Those are local variables. Global variables are variables defined outside of all functions, accessible to all functions within scope, can be seen as an easy way to share data between functions. Scope of a global variable and is from its point of definition to the program's ending. They should have bolded this, underlined it, highlighted it, used sparingly. Global variables are bad news. Why are they bad news? Because everything in the entire program has access to them and can modify them at willy-nilly as they want to, whenever they want to. That makes it very hard to create guarantees about what global variables contain, what data is stored in them. You don't always know. It's not always easy to debug because literally anything in the program can work with them. So initializing local and global variables. Locals are initialized by the programmers. Global variables are initialized to 0 or null. When the variable is defined, they can be overridden with explicit initial variables. So you can initialize numeric globals to 0, or char globals to the special sequence of characters called null. All right, again, why do we use sparingly? They make programs difficult to debug, cannot be reused easily in other programs, and the programs are just generally hard to understand. Trust me, they have bitten me in the past. Use global variables sparingly. Let's take a look at page 361. Here's an example. So it doesn't look like there's nothing special about its syntax. This int num2, it's very innocent looking. Its location in the program is a red flag to us, and how we know it's a global variable. It exists outside of any local scope. If int num equals 2 was inside of main, that would have made it a local variable. Because it was defined and initialized outside of main, makes it global. Now anything can access this variable called num2. So inside of main, num is, I guess, 2. Another function is going to call, and inside of another function, it's reassigning num to be 50. Oh my goodness, now back in main, num is 50. So you like have to keep track of it throughout the execution of all functions, including main and then including anything inside of main that may access it. We don't know. Bad news. Here's another one. Here's an uninitialized global variable, int global num. Which, yes, let me just back up. Because it is global, and yeah, the comment here is helpful. Global variable is automatically set to 0. So even though we didn't initialize it here, behind the scenes, because it is global, it's initialized to 0. So no equal sign anywhere within this program, but global num is 0. Global constants, though, are good things. And they are named constants that can be used for every function in a program, useful if there are unchanging values used throughout. They're safer to use in global variables since the global constant does not change. It's initialized once, and it's guaranteed to not change as the program executes. There's some pretty good examples on why you'd want to use this. So we've used constants in our programs before within main, but it would have been really good, totally acceptable to move those local constants outside of main and make them global constants. So up here, pay rate, base hours, and OT multiplier, because those are global constants, again, defined outside of main, main can use them, and any functions, get base pay, get overtime pay, can use them as well. Notice base hours, down here, base hours, pay rate, OT multiplier. Those are global constants that were defined outside of main, can be accessed anywhere within the program. You just can't change them. Why? Because they're constant. And that fact makes them much, much safer to use than global variables. Generally, when you talk about local and global variable names, so local variables, they're named like any other variable that we've talked about so far. But when global variables are named, typically, and you probably noticed this already, all caps, and we use underscores to separate words instead of using a space, which is illegal. Instead of using camel casing, we all caps the constant name and use an underscore instead of a space. Let's take a look at 365. Okay, this program demonstrates how a local variable can shadow the name of a global variable or constant. Let's back up in the slides here. Locals can have the same name as globals. This gets way confusing. Don't ever do this. When a function contains a local variable that has the same name as global, the global variable is unavailable from within the function. The local definition hides or shadows the global definition. If that sounds like a good idea to you, I don't know what to tell you. That sounds like bad news all over it. Like, you got to worry about variables shadowing other variables now? Gross. Talk about not debuggable. I'm not even going to do this example because it's a bad idea and you shouldn't do it. All right, static local variables though. Okay, so remember, local variables only exist when the function is executing. They're redefined each time the function is called, and they lose their contents when the function terminates. However, static local variables, defined with the keyword static, so it looks like this. It's just sort of a modifier before the data type and the variable name. Defined and initialized only for the first time that the function is executed, and they retain their values between function calls. This is kind of cool. Let's take a look at 366. Okay, 620. All right, function prototype. Oh, you know what? We know this. We know that local variables do not retain their values. I want to do a static one. Yes, here we go. Void show static. No inputs, no outputs. Here's the definition. Void show static, no inputs, no outputs. Here's the keyword static, int num calls equals 0. Cout, this function has been called num calls. I know I'm deviating slightly from the example. Num calls times. I need my angles. And it's sort of up to you. I'll say num calls plus plus. Increment it by 1. So the first time this runs, obviously num calls is 0, but let's try it. Maybe you want that to say 1 initially, so you just initialize it to 1. Up to you. Oh, we need to change our main for int count equals 0, count is less than 5, count plus plus. Show static. Okay, notice how it's incrementing by 1 each time. If we did not use the static there, we can even just try that. If we removed static and just did what we've always done, you can guess what we're always going to see. Always going to see 0. Even with that increment here, it's always going to be 0 because it's always getting reset each time show static is called. So that is the static keyword. Default arguments. So worth mentioning, values that are passed automatically if arguments are missing must be a constant or a literal declared in the prototype or header, whichever occurs first. So it could look something like this. So void, not returning anything, function name, followed by your parameter list. So here we have an int called x, and we're initializing it to 0. That makes it a default argument. So if the user, when they call this function, does not specify any value passed in here, it's going to default to 0. Multiple parameter functions may have default arguments for some or all. I know in C#, all of your optional, or I should say default parameters must occur at the end of the parameter list. So here we have an int. Int must be specified by the caller of getSum, but this int and this int could be omitted and they will just be defaulted to 0. If not all the parameters to the function have a default value, the ones without defaults must be declared first in the parameter list. So yeah, C++ is the same as C#. So this is good. The defaults are at the end of the parameter list. This is invalid because you have a default here and 2 regular ones surrounding it. So when an argument is omitted from a function call, all arguments after it must also be omitted, like so. There's no like blank arguments allowed here. Let's take a look at page 370. Okay. Let's do 622. All right, void function called display stars accepts an integer called stars per row, which is going to default to 10, and an int num rows, which is going to default to 11. What is that going to do? Void display stars, int stars per row, int num rows. Notice here, we did not specify the defaults down in the implementation. The defaults were defined up in the prototype, but not in the implementation. We left off the equals 10 and equals 11 from here. So we're going to have 4 int row equals 1. Row is less than or equal to num rows, row plus plus, basically printing a table here. an inner loop for int star equals 1, star is less than or equal to, I can type stars per row, star plus plus. And then we'll see out a character. So we're going to see out the character asterisk. And then outside of the inner for loop, we're going to see out an end line. Cool. We need to call it, of course, and activate it. And this is going to show us, if you're not convinced already, why functions are so cool. So display stars, we can call it with nothing. We can display stars with 5, and then the second parameter is the optional one, so it'll be set to 11. We can call display stars with both parameters, 7 and 3. And that'll work just fine. Return 0. Cool. So default parameters, 1 optional, both are supplied. Okay. Using reference variables as parameters. So this is a mechanism that allows a function to work with the original copy. This is the opposite of what we were talking about earlier with by value. This is what's called by reference. So in this case, we're working with the original argument from the function, not a copy of it. Make sure you understand this. It's not a copy. It is the original thing that is passed in. Allows the function to modify the values that are stored in the calling environment. Provides a way to for the function to return more than one value. There's some syntax here. So a reference variable is an alias for another variable. When used as a function parameter, it's defined with an ampersand in the prototype and in the header. Changes made to a reference variable are made to the variable it refers to. Again, it's not a copy, it's the actual thing. Use reference variables to implement passing parameters by reference. Here's a good example. So we have a function prototype called squareIt, which accepts some integer referenced. That's kind of how we say that. It accepts a reference to an integer. The implementation looks like this, where we have the int data type ampersand num. So a reference to some integer called num. We are just taking num times equals num, squaring it. And down here is where we're calling it. Int local var equals 5, so square it, passing in local var. Now, when local var is referenced later on in the program, it will contain 5 times 5, or 25. A good example to take a look at a hands-on. Yes, the syntax is a little confusing here. This is the first time we're encountering the syntax, but when we get into the chapter on pointers, this will make a return. Pointers are kind of the notorious subject in any of your intro-level C++ courses. But this is like the first part of pointers. All right. A function prototype called double num int ampersand ref var. So a reference to an integer with that ampersand in there. Down here, void double num int ampersand ref var. Ref var simply times equals 2. We're just doubling it. To call this thing, we're going to have int value equals 4, cout, in main value is value, end line. Now we're going to call double num, passing in value. Now we're outside of that function call, now back value is. Okay. So if we were just doing normal parameter passing, not by reference, by value, both of these would say, can you guess? They would both say 4. But because we're passing by reference, now we're going to see something different. If I activate the project, 623. In main, value's 4, now it's 8. So we took that original value in this variable, passed it down here by reference, multiplied it by 2, and we're done. We're basically modified the original value. The textbook gives all kinds of deeper explanations into this, and there's diagrams and all kinds of good stuff. So if this doesn't make sense to you, make sure you review this section of the textbook. It is critical that you understand this difference between passing things to functions by value versus by reference. It's a critical difference that you must understand to move forward to the more advanced topics of the course. So make sure to review the textbook. Reach out to me if you need help understanding this difference. I can do more examples, more explanation, whatever. Okay, each reference parameter must contain an ampersand. An argument passed to a reference parameter must be a variable, cannot be an expression or a constant. Use only when it is appropriate, such as when the function must input or change the value of the argument passed to it. Files should be passed by reference, because if we're working with a file inside of a function, we want to work with that file by reference. We want to work with the original file, not a copy of it. Here's some more examples. So 374. Getting close to the end here. Okay, we'll just read through these. So we've got 2 function prototypes, one called getNum, one called doublenum. So getNum accepts a reference to an int. Doublenum just accepts an int. So getNum, okay, all it's doing is taking that reference and cinning into it. So it now contains the value that the user types into it. Doublenum is going to return whatever is passed into it times 2. So back in main, getNum, so int value, getNum is going to be cinned, okay? We're going to have whatever value the user types into it because it was passed by reference. Because doublenum was passed by value, we're passing in a copy of value and assigning to it the result of doublenum with value passed in. Make sure you understand that. Calling doublenum, passing it the number stored in a value, assigning the value, the number returned by the function. This is kind of how I think about this, is this is like a way of simulating calling it by reference. We're still calling it by value, but we're reassigning value after we pass it into the doublenum function. We're still achieving the same thing as if we would have passed it in by reference, and then we're just displaying the output. Okay, this program illustrates 2 appropriate uses of passing arguments by reference. So function prototypes. GetNums, 2 references, 2 integer references, and OrderNums, 2 reference, 2 integer refs. Okay, down here, because we're passing by ref, we're going to cin to input 1, cin to input 2, and those are going to be stored in small and big. And now we can order those. And this is a simple little ordering algorithm, so just testing to see which number is bigger and reordering them accordingly. If they're out of order, swap them. Because we're passing them by reference, we're working with the original values and swapping their contents if they are out of order. Let's see, let's go to 378. And this one is, I would highly recommend, there's nothing like new in this one, but I'd recommend you guys work through this one on your own using the textbook weather.dat file. This will illustrate passing that file into a function by reference. Passing in the original file and working with it by reference, not a copy of it. To try to keep this thing somewhat compact, I'm going to keep moving on to the next topic. Again, please reach out if by value, by reference does not make sense. It is fairly nuanced. Okay, what does it mean? I think this is, almost the last topic here. Overloading a function. So the signature of a function is the function name and the data types of the parameters in order. The return type is not part of the signature. Overloaded functions are two or more functions that have the same name but different signatures. So you can have two functions, same name, but different signatures. Can be used to create functions that perform the same task but take different parameters or a different number of parameters. Then the compiler kind of knows, based on how you call the function, which one you're meaning to call. In this case, we have 4 functions with the same names, but different signatures. So one accepts a single int, one accepts 2 ints, one's an int and a float, one is 2 doubles. So you can call them just as you would need. So if you need to use the get dimensions with 1 parameter, the compiler would figure that out. Or 2 ints, an int and a float, double double. I'm going to skip a couple of those. Exit terminates the execution of the program. Can be called from any function, so this just shuts the program down. You do have to use a additional header file, cstdlib. Use with caution. Use an integer to indicate the program status. 0 can mean successful, or non-zero could mean a failure. So anything other than 0 could mean that the program did not finish successfully. And you can use the named constants. So in this library, cstdlib, they've defined some constants called exit success and exit failure. And you can just use those to indicate if your program completed successfully or not. Okay, some terminology here. Stubs and drivers. A stub, a function stub, is a dummy function used in place of an actual function. Displays a message indicating that it was called. It may also display the values of arguments. So nothing like super profound here. Stub functions are just ways of like indicating that this is the function's name. This is the inputs it's going to accept and the outputs it's going to give back, but no actual implementation yet. It's stubbing it out. A driver then is a function that tests a function by calling it. Stubs and drivers are useful for testing and debugging program logic and design. Let's see what we have left here for hands-ons. We're nearing the end. Page 390. Yeah, so here's a driver for our kind of adult child senior rate program we've been working with. Testing the show fees function. So here's a function prototype, show fees. Here's the named constants that we're familiar with. Show fees, show fees, show fees, and performs a test. I mean, yeah, sure, it's testing it. It's executing with these inputs. All right. This is one of the bigger ones. I think we'll conclude here. The program finds a probability of winning a mini lottery when the user's set of numbers match exactly the set drawn by the lottery's organizers. In addition to main, it uses 3 functions. All right. Let's take a look. So we've got 3 functions here: get lottery info, 2 reference integers. We've got compute ways, 2 integers, and something called factorial, which accepts 1 integer. We've got some local variables here. Actually, let's check out the function implementations first. So get lottery info gets and validates lottery info from the user and places it in reference parameters referencing variables from main. So it's going to modify the original values passed into it from main. So it's going to ask how many numbers are there to pick from. So this is like you're sort of setting up or initializing the lottery yourself. So how many numbers are there to pick from? So it's going to limit you to choose between 1 and 12. And it's going to keep looping until you enter in valid data. How many numbers must you pick to play? So that's like a range between 1 and whatever was passed down here for pick from. And then it's going to loop until you enter valid data. So that's basically getting the inputs from the user, getting the game set up. On the next screen here, we've got some math, good stuff. Compute ways, computes and returns a number of different possible sets of k numbers that can be chosen from a set of n. The formula for this is, they give it here. If you don't understand this formula, that's fine. It's probability stuff. But here it is. And just so you know, n factorial, you can look that up on Wikipedia, but that basically means like if you have 5 factorial, that's the equivalent of saying 5 times 4 times 3 times 2 times 1. Those get really big really quickly. It's just a long chain of multiplication. So n factorial, so n numbers divided by k factorial, possible sets of numbers, times n minus k factorial. So very, very large numbers that you're working with here. So note that the computation is done in a way that does not require multiplying 2 factorials. This is done to prevent any intermediate results from becoming so large that it causes an overflow. So because of that, even so, they have a long int here because these numbers, again, are going to get big. And we're in this compute ways function, so which is this math equation. We're calling another function called factorial. So factorial is done down here. Most, I would say, programming languages have a built-in factorial function. I'm not sure if C++ does or not, but it doesn't matter because we're doing it ourselves down here. Remember I said factorial is the number times the number minus 1, minus 2, all the way down to 1. So again, if you passed in 6, it would be 6 times 5 times 4 times 3 times 2 times 1, and that's done here in this for loop. You're sort of keeping a running total and then returning it. And this basically is the translation of this math function. Back inside of main is what we would expect. Prompting for input, computing the number of ways, and then displaying the chances and probabilities of winning. Pretty fun program. I'd recommend typing it out yourselves and running a few test cases to see your chances of winning the lottery. Okay, that will do for Chapter 6, a whirlwind tour through functions. I know, kind of went through it quickly in order to make these lectures, these videos a little bit more bearable. My recommendation is go through the videos, but speed things up, but slow things down as you need to. Again, they are also on YouTube, which has that variable playback speed. So feel free to do that. And then the parts that you find that are difficult, like by value, by reference, then go back into the textbook and really read in detail some of the notes and illustrations that they have there for you. Do recommend reading the book in its entirety, I know, but in particular, especially those concepts that aren't making sense in just the lecture videos and PowerPoints. You guys are learning how to program in a time that's a lot nicer and much more friendly than when I learned to code when I was younger. All I had were like inches thick programming manuals that were obsolete in a year. Just physical textbooks that I had to read from. You guys can watch YouTube videos on any of this stuff if it's not making sense. So do that, dive deeper, make sure the stuff is making sense as we move on to the more, I would say, interesting and difficult parts of the C++ programming language. As always, check out the assignment for Chapter 6, and we'll see you next time.